Okay, so we're going to go over basically everything that we've covered in the past month. As far as what it means to graph quadratics, we started with vertex form, then we went over to factored form for a little bit, and then recently we've done standard form. So there's three different forms that we've been able to do. We're going to talk about each one and why that each one is important and why each one is maybe doesn't have everything that you need. Okay, so let's talk about vertex form first. That's the one that we did for a few weeks. Vertex form looks like this. It looks like y equal to a times x minus h squared plus k. And the reason why this one's important is because it's really easy to find the a value. Remember that a value tells me whether something is concave up or concave down. It also tells me the vertex is at h comma k. Now what I mean by that is this one tells you how it moves left and right. This one tells me how it moves up and down. And once you figure out what the shift is, right, moves this many units left and this many units up, then you know where the vertex is at. So it's really easy to see the shift. The line of symmetry always goes through the vertex. So you should be, once you get your vertex, then you should know where the line of symmetry is. So those are all the pros of having something in vertex form. But most importantly is you can see the shift and you know exactly where the vertex is at, okay? Some of the cons is it doesn't tell you the y-intercept and it doesn't tell you the x-intercept. So these are some of the things that are not so good. Let me go ahead and highlight that. These are your pros and these are your cons. Okay, now here is what's of interest of you for to you. So I'm put a little note here. If you want to change it from standard form, which is y equal to ax squared plus bx plus c, and you want to change it to vertex form, then what you need to do is you need to isolate the x's on one side and you need to complete the square. Hopefully I'm saying that and you're like, oh, I kind of remember what that sounds like because we're going to go over what that actually means in a little bit. Okay, so there is vertex form in a nutshell. Let's talk about factored form. Factored form, we did not spend too much time on it. In fact, I think we spent 2 or 3 days on it, and that was it. Factored form looks like this, and I did not give you the formula for factored form. I just kind of did it and said, "Oh, look, it's factored." Really, really well. Let's talk about the pros first. So again, just like last time, you can see its a value, and a value will tell you whether it's concave up if it's positive, or if it's concave down if it's negative. Okay. It's also really easy to see the x-intercepts or the roots or the zeros, and we'll talk about what that means later. The line of symmetry is going to be in the middle of the two roots. So actually, let's talk about it right now. When you do your x-intercepts, you're going to get two dots, right? Those are your x-intercepts. That's where it crosses the x-axis. To find the line of symmetry, you're going to find the middle of those 2 points, okay? And that's going to give you the line of symmetry. Now, some of the cons. So that was the pros. That's the benefits of having something in factor form. So you can look at the a value. You can see the line of symmetry. You can find the x-intercepts. Some of the not so good things of having it in factor form is it's hard to see how your graph is shifting. So it's not so easy to pick off like, that it moved this many units to the left or this units to the right. It doesn't tell you the y-intercept, okay? And you have to use the line of symmetry in order to find the vertex. That's kind of cumbersome, but it is what it is. So here's the important part, some note. If I'm going to go from standard form to vertex form, I know it says a lot of stuff, but we're just going to kind of ignore this stuff. Ignore this for now. Guys, you're trying to go from from standard form to vertex form. What they're really saying is, I'm sorry, you're going to go from standard form to factor form. That means you need to factor it. Just factor it all the way. Okay. First, you're going to factor out the GCF. That's what you normally do when you factor it, and then you're going to factor it again, and that's all you really got to do. Okay. Again, we'll look into it in a little bit, and then the last one is standard form. Actually, standard form is probably the hardest of the bunch, but because it's the one that we did the most recent, it's probably the one that you're kind of most familiar with right now. So even though mathematically it's the hardest to do, it's the one we just did. So students tend to remember what we just did. So what are the pros for standard form? Well, again, I know my a value, right? I can pick off my a value. My a value is right here. My a value, if it's positive, will be concave up, and if it's negative, will be concave down. If I have it in standard form, I can find the vertex. I just need to do negative b over 2a and f of negative b over 2a. I can also find the y-intercept, and that's something that the other ones can't do. And in order for you to do the y-intercept, you're just going to go 0, comma c, where c is this number. If you don't know what I'm talking about, then the better way of doing it is just plugging in x equals 0, and then this is going to be gone, this is going to be gone, and then that'll give you the c that we're talking about. And you can always find the line of symmetry because you know where the vertex is at, right? Since you know the vertex is at negative b over 2a, f of negative b over 2a, then your line of symmetry is going to be x equals some number, and it's always going to be this number right here, right? Your x value from your vertex, and that's it. Some of the cons is just like factored form, you can't really see the shift, and you don't know where the x-intercepts are at. I have a note here, but we're not going to touch that for right now. We're just going to kind of skip over it. And the last thing we're going to talk about is our parent graph. Our parent graph is the most basic version of our graph. So this is the graph of y equal to x squared. And if I'm going to plot the points for y equal to x squared, you should know these points, which is 0, 0, 1, 1, 2, 4, 3, 9. Those are the points that you need to have memorized from this graph. Those aren't magical points. The way you get those is you just square the number, your x value. So if I take the 2 and I square it, I get 4. If I take the 3 and I square it, I get 9. The next dot should be 4, and when I square it, I get 16. So your next dot should be at 4, 16. And that's what the parent graph looks like. And as always, my line of symmetry is right here. So you can always get these other dots, just mirror it on the other side. Okay, so that's a brief review. I forgot to highlight this. Let me go ahead and do this right now. These are the pros from standard form. These are the cons from standard form. And you can go ahead and put stars around this note, but we're not going to be using it for now. Okay, so there's our review of the stuff that we've done in the past month. The other thing I need you to make sure of is you need to make sure that you cover all the vocab from topic number 11. So make sure you go back to topic number 11, and it talks about what it means to be the domain, and what it means to be a vertex, what it means to be a line of symmetry, what it means to be the range, what it means to be increasing, what it means to be decreasing, all that wonderful stuff, okay? All right, so there's our overview. Now, I know I did all that overview, and you're kind of looking at it and going, what the heck are we talking about? So I gave 3 examples, one from each one of these topics, so you can kind of see how each one works, okay? The important thing is you understand which form you're working on. If you're working under vertex form, then you should be looking at this quadrant here. If they're asking you to do in factor form, then we should be worried about the information over here. And if we're talking about something in standard form, then we should be worried about this information right here. Okay, so let's go ahead and you go ahead and copy this down. I'm going to go ahead and pretend that you already did that. It says convert y equal to negative 3x squared minus 12x minus 8 into vertex form and describe the graph. So let me go back over here. I want to convert this that's in standard form into vertex form. Vertex form, if I want to change it into vertex form, the directions say that you need to isolate the x's on one side and complete the square. So that's exactly what I'm going to do. I'm going to rewrite this, and I'm going to write y equal to negative 3x squared minus 12x minus 8. And I'm going to go ahead and isolate the x's on one side. So I'm going to go ahead and swing that 8 over to the right. I can do that by adding 8. I get y plus 8 is equal to negative 3x squared minus 12x. Now, normally at this point, you would start completing the square by taking your b, which is negative 12, taking half of it, square it, add it to both sides, and then moving on. Unfortunately, because there's this number in front of the x squared, it messes everything up. Okay, so before I start completing the square, because there's a number here, by the way, there's not always going to be a number there, but there is a number there in this case. I need to factor that number out. Okay, just the number, not the x. So I'm going to factor out just the number, which is negative 3. And I'm going to go ahead and leave the x squared minus, to get it back, let's see, I need an x squared, and I need I need a positive 4x. Okay. So that's me factoring out the negative 3, not the x. Leave the x there, okay? And I get a y plus 8 over here. All right. Now at this point, I'm going to go ahead and take my b. My b was 12, but because I did that factoring, my new b is 4. So I'm going to take my new b, which is 4. And with this, I'm going to take half of it, so it becomes 2. Then I'm going to square it. 2 squared, that becomes 4. and I'm going to add it to both sides. Kind of. I'm going to add the 4 kind of to both sides. So let me show you what I mean by that, because this is a little bit tricky in this case. This is -3 parentheses x squared plus 4x plus 4. Now I say I added 4, but I really didn't. And the reason I really didn't, let me put a little thought bubble right here, is because that's not a regular 4. That's a 4 that has a -3 attached to it. So really, this is a -3 times 4. Okay? A -3 times 4, that's a -12. So what I really did was I added -12 to each side. I'm going to go ahead and put this here. In fact, let me go ahead and start color coding my steps. This was my yellow step. I took my B, and I took half of it. This is my pink step. I took that half, and then I squared it. And then this is my green step. I took that number, and I added it to both sides. So it kind of looks like I'm adding a 4, but I really didn't add a 4. I added -12. Now, since I added -12 to the right side, again, I added -12 because it's actually -3 times 4. Because I added -12 to the right, I need to add -12 to the left to keep it balanced. Okay, so I'm going to write y plus 8 minus 12. That 8 minus 12, that's going to give me a -4. So I got y minus 4 is equal to -3. Now, that x squared plus 4x plus 4, I'm going to go ahead and factor it, right? That should factor to a perfect square. Most of you guys will see the perfect square, but if you don't, then you're going to factor it the long way, which is like this. Put it parentheses x, parentheses x. You're going to find numbers that multiply to 4 and add up to 4. Well, that's either 1 and 4 or 2 and 2. And it looks like 2 and 2 is going to be the one because it adds up to 4. So it's going to be a +2 and a +2. Now, this is not a coincidence that you got the exact same thing twice, that x plus 2 times x plus 2. We completed the square, so you should get the same thing twice. If you don't get the same thing twice, you did something wrong. So on the right-hand side, I got -3 parentheses x plus 2 squared because I have 2 of them, okay? Now on the left, I'm going to get rid of that -4. The way you get rid of that -4 is adding 4 to both sides. So if I add 4 to the left, it goes away, and I'm left with a y. And when I add 4 to the right, I'm just going to stick it at the end. And this is now in vertex form, okay? I was able to do the first step, which is put it in vertex form. Now that I have it in vertex form, now I'm going to go ahead and write down all the things that I know about this graph. The first thing I'm going to do is I'm going to talk about that -3. That's my A value. My A value is -3. Since it's -3, I know that this thing is going to be concave down because it's negative. And because it's being multiplied by 3, I know it's going to be a vertical stretch by a factor of 3. This thing is vertically stretched. Okay, so that's what my A value tells me. The other thing I know, and this is important because it's in vertex form, is I know it's shifting, right? This controls left and right, and it does the opposite of what you think. So it's going to go left 2. And this goes up and down, and this is going to be up 4. So it's going to go left 2, up 4. I'm going to put a dot, and that's where my vertex is at. If I go left 2 on my graph and up 4, then those coordinates would be -2, 4. That means my vertex is at -2, 4. So I know it's concave down. I know it's vertically stretched. I know my vertex is at -2, 4, and I should be able to figure out one more thing. And that one last thing is, where is the line of symmetry? The line of symmetry is always passing through your vertex, and it's always x equals something. Remember that this is your x, y right here. It's x equals something, and it passes through your vertex. Your x needs to be -2. So I can say that the line of symmetry is at x equals -2, except we're going to introduce some new vocabulary here because this is what they do in the benchmark. Instead of the line of symmetry, they call it the axis of symmetry. It's the exact same thing. Axis of symmetry, it's the same thing as my line of symmetry, and I know that that's at x equals -2. Okay, so if I were to graph it, I would know all those things before I jump into my graph. And you'd be able to get a pretty good sketch of what this graph looks like. That takes care of the first one. So now you know what I mean by all of this stuff right here. Notice that we covered pretty much all the pros. I used the A value. I talked about the vertex. I know the way it's shifting, and I talked about my line of symmetry. Okay. All right. The next problem says convert y equal to 2x squared plus 4x minus 16 into factored form and describe the graph. Now, I would go back and show you what factored form means again, but I would rather you get those key words. They're saying in form, factored form, which means you need to factor it all the way. And that's really all you got to do, okay, to get this in factored form. We need to factor it. So let me go ahead and write down the equation. That's going to be y equals 2x squared plus 4x minus 16. Okay, I want this in factored form, which means I need to factor it. The first step in factoring always is to find the GCF. And I do have a GCF. That's going to be a 2. So I'm going to write y equals 2 parentheses. Now I need to get this thing back. I get x squared plus 2x minus 8. All right, now I look at it and I say, oh, I can factor that again. So I'm going to go ahead and do that. I'm going to factor this again, and I get y equals 2 parentheses x parentheses x. Hopefully you can do this in your head. If you can't, you got to make a list. I need numbers that multiply to 8 and add up to positive 2. So I know that's either going to be 1 and 8, 2 and 4, 4 and 2. But that one doesn't work. So it's got to be one of these. Looks like the 2 and 4 is going to work. If I want a positive 2, though, I need this to be positive and I need this to be negative. So this is going to be a minus 2 and a plus 4. This is in factored form. Look how similar this looks to this right here. All right, it is in factored form. All right, so let's talk about why we will put something in factored form. Let's talk about my graph. I know for a fact you can always talk about your a value. It doesn't matter what method you're using. So my a value is 2. Since my a value is 2, I know that it's positive, so it's going to be concave up. And because I have 2, 2 is a number bigger than 1, and when you multiply by a number bigger than 1, it's going to make it stretch. Okay, so this is going to be a vertical stretch. That takes care of my first thing. Let's take care of the next things. I should be able to find my x-intercepts. My x-intercepts are what makes this thing equal to 0. So my x-intercept, this first one, is going to be at x equals 2. That'll make this 0. And the other x-intercept will be here at x equals negative 4. That'll make it 0. These are my x-intercepts. Those x-intercepts, they can call them the x-intercepts. They can call them the zeros. They can call them the roots. They're all the same thing. So what they're saying is if I were to graph this 1, 2, 3, 4, and then negative 1, negative 2, negative 3, negative 4, my graph would have x-intercepts at 2 and negative 4. So on my x-axis, it's going to cross right here at 2, and it's going to cross right here at negative 4. Okay, so I know my x-intercepts. So let's go ahead and write that. X-intercepts at. Now, x-intercepts, if you look on the graph, those are points. And if they're points, then you should be writing these points as coordinates. That's going to be 2, 0 and negative 4, 0. So the x-intercepts at negative 2, 0 and 4, 0. Okay, so I know my x-intercepts. That's great. Let's talk about the next part. You can, if you have the x-intercepts, you can find the line of symmetry. And the way you find the line of symmetry is you can use your fingers to try to work your way to the middle. Now I say it, I'm laughing because on one of them, on one of my classes yesterday, I could not find the middle. I was just not using my fingers correctly. So when you're having trouble like I was yesterday finding the middle, you can always find the middle number by just averaging the x-intercepts. What I mean by that is you're going to add the numbers up and divide by 2. That's how you find the average, the middle of those two numbers. So we're going to add the two numbers up. That's going to be 2 plus negative 4 and divide it by 2. That's negative 2 divided by 2, and you get negative 1. The middle number must be negative 1. Let me go ahead and do this in red so it kind of stands out. This is the middle of those two numbers, which is great. That means my line of symmetry is going to go right through here through negative 1. So my line of symmetry, sorry about that, my hat kind of slipped. My line of symmetry is the equation x equals negative 1. So let me go back over here. I know that my line of symmetry, they will call it the axis of symmetry. And then if they get really lazy, they're going to call it this. My AOS, which is my axis of symmetry, is at x equal to -1. Now, that red dot, let me go ahead and get rid of that red dot. I don't like that red dot. Kind of makes it look like it's a point on my graph. It's not, okay? It's a line of symmetry, x equal to -1. Now, I'm going to use that axis of symmetry, the x equal to -1, because I don't know where the vertex yet. The vertex might be up here. The vertex might be down here. I say that, I'm lying. I know that one of those is not right. This is concave up. So since it's concave up, it's going to look like this. And if it's going to look like this, then that means my graph's got to do something like this. So I know my vertex got to be somewhere down here. There's no way it's going to be up here, because then that would make it concave down. Okay, so I know my vertex is sometime down here, but I don't know how far down. What I do know is that it's somewhere here. And if it's somewhere here, then that means my x must be -1. What that means is my vertex must be -1, comma something. I don't know what that something is, but I can find it out really easy, because you know what I do know? I know my x is -1. So I'm going to use it. I'm going to use my x is -1. I'm going to plug it into my equation so I can figure out my y. Check this out. I'm going to write y is equal to 2 times x squared. But again, I know my x is -1 squared plus 4 times, oh, there's an x again, so I'm going to replace it with -1. And then minus 16. Y equals, now remember, sorry, let me do that in red so it kind of pops out. Y equals, now here's where you have to be careful, and this is where students have been messing up. You need to do this part first. So on your calculator, you want to type it just like that, parentheses -1 squared. You should get a +1, okay? And then +1 times 2, that gives me a +2. 4 times -1 is -4. And then -16 here. Something. Nope. That's right. Sorry, I thought I was doing something wrong, but I'm not. Okay. So you get 2 minus 4, which is -2, minus 16, that's -18. I just found out that my y is -18, and I know my x is -1, so that means my vertex must be at the point -1, comma, -18. I used the line of symmetry, fact that x is -1. I plugged it in, and I got my y value. So now I know my x and I know my y. So I'm going to write vertex at -1, comma, -18. And that's all I need to know about my graph. Notice that it's kind of hard to get the vertex, right? Like first you have to get through 2 x-intercepts, and then from there you're going to find the middle, and that gives you your line of symmetry. Then you're going to use your line of symmetry to plug it in and get the last part of your vertex. I know it's a lot of work. It's not hard. It's a lot of work, and you need to memorize the steps. All right, last one. I want to describe the graph of y equal to -x squared plus 4x minus 3. This is in standard form. They didn't tell me to put it in vertex form. They didn't tell me to put it in factored form. So I'm going to go straight from here. That means I'm going to go and do the stuff here. I'm going to use my a value. I'm going to find my vertex by using -b over 2a and f of -b over 2a. I'm going to find my y-intercept by plugging in x equals 0. Okay. All right. So let's go ahead and do all of that stuff. Sorry for me scrolling up and down. I hope I'm not getting you dizzy, but I think it's absolutely necessary in this case. So the first thing, you know what? Let's go ahead and start describing. I know my a is -1, and since my a is -1, then that means this is going to be concave down because it's negative. And because it's a 1, this doesn't have a vertical stretch, and it doesn't have a vertical compression. It's just going to be concave down. Okay, so I already talked about my a value. Next thing is the vertex. They said I can find the vertex by using -b over 2a, comma, f of -b over 2a. Guys, one of the biggest mistakes I've been seeing when we do the -b over 2a is students are forgetting to write the stuff that they put in parentheses. Substitute your stuff in parentheses. It makes a difference. Okay, so what I mean by that is when I do negative b over 2a, I'm going to write negative because of the negative, parentheses, and then use my b. My b in this case is 4. So in the parentheses, I'm going to write 4. If your b was negative 4, then you would write negative, parentheses, negative 4. And then you would get a negative negative, which would turn it into a positive. And that has been the number one mistake I've been seeing a lot is students not plugging stuff in parentheses and then them accidentally losing a negative. Okay. On the bottom, I'm going to write 2 times a. A is a number. I'm going to put that in parentheses. My a is negative 1. So I put that negative 1 in parentheses. That gives me negative 4 divided by negative 2, which gives me a positive 2. What did I just find? I found the first part of my vertex. It's 2, my x value, right? Now that I know my x value is 2, I'm going to find my y value by plugging it in. So I'm going to substitute that 2 back into my equation. Anywhere I see an x, I'm going to replace it with the 2 that I just found. Okay, so I'm going to write y is equal to negative, parentheses, 2 squared, plus 4 times 2 minus 3. Y equals, again, we're going to do this part first. 2 squared is 4, and then multiply it by a negative. That's negative 4 plus 8 minus 3, and that becomes a positive 1. What did I just find? I found the second part of my vertex, which is my y value. So now I know where the vertex is at. The vertex is at 2, 1. So let's go ahead and write that. Vertex at the coordinate 2, 1. Since I know my vertex is at 2, 1, then I should know the line of symmetry. Remember, the line of symmetry, you need to always write it as x equals. So I'm going to write axis of symmetry. And you need to write it as x equals. So this is going to be x equals, and then whatever your x value is on your vertex, x is 2. So then you're going to write x equals 2. And then the last thing you can find is the y-intercept. So let's go back over here because I know you probably forgot this part. Check this out. I already talked about the a value. That's how I knew it's concave down. I already found the vertex. Great. I need to find the y-intercept. Okay, I haven't done that one, and I already did the line of symmetry. That one's good to go. Y-intercept is the one I need to do. And it's either at 0, c if you remember it, or if you don't remember it, plug in x equals 0, which is what we are going to do. We're going to plug in x equals 0 just in case you forgot how to do that. So plug in x equals 0. That's going to be your y-intercept. Y is equal to negative 0 squared. Let me put that in parentheses. Negative 0 squared plus 4 times 0 minus 3. This goes away because it's 0. This goes away because it's 0. That means y is negative 3. When I plugged in 0, I got negative 3. That means my y-intercept is at 0, negative 3. That's where it touches the y-axis. Okay, that is all the notes for today. Hopefully that was a refresher and it's making sense. And you're like, oh yeah, that's right. I remember how to do that. As always, if you have any questions, let me know. You do have one more day to study for your quiz. And so hopefully this was a great help.